Hi everybody, Mrs. Cox here again. So my Zoom was not working at all today. And in fact, it even crashed in the middle of our lesson. So regardless of whether or not you were able to come, I wanted to go ahead and redo our lessons for today because since our technology wasn't really working, I wanted to make sure that everybody was still able to get the concepts that I was hoping to cover. So we're going to start out with time today. So I am going to share my screen with you here. And we're going to start with a little bit of telling time. I have been working with a few students individually on telling time. And I've even sat down with a couple of people and done their flash math with them. And so I wanted to talk about some of the things that I saw people were struggling with the most on their splash math this week, especially on the time levels. So the first thing that I wanted to talk about is the language that is being used when we talk about time. So we talk about being past the hour, and then we talk about until the hour. So whenever your minute hand is from the 0 all the way around this side of the clock until the 30-minute mark, this half we talk about as being past the hour. Sorry for my drawing on here. And then when the minute hand is around this half of the clock, we talk about that being to the hour, to the next hour that has not happened yet. Or sometimes people will say till or until the hour. So we have past on this half of the clock, right? We have past on this half of the clock, and then we have to on this half of the clock. Now, when we're discussing past, we're talking about the hour that has just gone past. So for example, if I move this around right now, one way to say this time would be 7:10, right? So the time would be 7:10. Another way to say 7:10 would be 10 past 7. 10 past 7. So that's how that language works. So you talk about what hour it has just gone past. On the other side over here, let's move this guy around a little bit. Let's say that it lands right here. When we use the word to when we're talking about time, that means that we are talking about how long it's going to take for the minute hand to get to the 12 or to get to the next hour. So you can see right here, this is 8:50. So the current hour is 8, but the way that we would say this is 10 to 9. So it is 10 to 9 or 10 till 9. What that means is that if you count by fives from the minute hand to the 12 like this, 5, 10. It will take 10 minutes until it is the next hour or 9 o'clock. It will take 10 minutes to get to the next hour, 10 to 9. See that? If I move my minute hand those 10 minutes, it becomes 9 o'clock, 10 to 9. So let's do a couple more here. So I have right here, I have 10:20. The other way I could say this is 20 past 10. 10:20 is the same as 20 past 10. Now let's continue to move our arrow around, our hand around. Let's leave it right here. So 10:40. Now look, I'm on the 2 side of the clock, right? What time will it be? Whoops, sorry, I hit a button. So what time will it be? Soon. So you have to think, when you're using the to language, what hour will come next? What hour will come next? Well, in this case, the next hour will be 11. Let's find out how many minutes it will be until 11 o'clock. So we count by fives. 5, 10, 15, 20. So here I could say 10:40, or I could say it is 20 to 11. 20 to 11. And if I were to move this around 20 minutes, 5, 10, 15, 20, take a look. Now it's 11 o'clock. So 10:40 is the same as 20 to 11. So hopefully that will help you in your splash math. Anytime the minute hand is on this time, you are talking about it is past the current hour. Anytime the minute hand is on this side, you are talking about how it is to the next hour or until the next hour. All right. Well, that's what we have for time today. Now, the other quick thing that I want to talk to you guys about today is our science. So we've been talking a lot about weather, and we're going to move on from weather to oceans. So I will share my screen with you one more time here, and so that we can see what we're talking about. Okay, so I have, and let me go ahead and make that nice and big for you. There we go. Okay, so weather and oceans are really interconnected. They are very related to one another. The oceans affect weather, and weather affects the oceans. So they are in a cycle together. In fact, they are a huge part of the water cycle. There are 6 main oceans in the world. There is the Atlantic Ocean right here. So if you look at the globe here, here's the United States, North America, United States, Mexico, Canada. Here is South America. Here is Africa. And here is Europe, right? Asia and Australia. So the Atlantic Ocean sits between these major continents right here. We have the Indian Ocean. This right here is actually India. So that can help you remember the Indian Ocean is right by India. We have the Pacific Ocean, and if you notice, it's on 2 sides of the screen. That's because if you think of the world as a ball, which is what it is, and if this were wrapped around to touch, those 2 parts would be touching each other. This is just one way to show the map. The Pacific Ocean is actually the largest ocean on our planet. Then we have 2 much smaller oceans. We have the Southern Ocean down by the South Pole, and then the smallest ocean is the Arctic Ocean up by the North Pole. So those are all of the poles, all of the oceans on our planet. Those are the main oceans. Now, right here, what I have is a diagram of what happens and how the ocean is connected with weather, okay? So we already know that the sun heats up the surface of the water. And when the surface of the water heats up, it begins to evaporate. Good, it begins to evaporate. When it evaporates, that warm air rises up. And there's cold air that has gotten cold up in the top of the atmosphere that starts falling down to take its place. When it falls down, it creates wind, which rushes across the surface of the water and in its turn forms waves. So that's one way that waves are made. But so this big cycle of the water cycle and the air helps to create our weather, because as the water evaporates, it goes up and creates clouds, right? And then which will precipitate and keeps going in the cycle. And it also changes the way the ocean surface is through that wind. And the last thing I wanted to show you today is underneath the ocean, so the ocean floor. Our ocean floor is not flat and smooth. It is very, very bumpy. And I know there's a lot of labels on this picture, but there's just a few that I want you to focus on. So the first one is right over here. This is our beach, okay? That is the spot where the water meets the land, okay? Some beaches are really wide, have lots of sand. Some beaches are rocky and small, and some beaches are just a cliff face or even just mud sometimes. But that's where the water meets the land, and that's also called the shoreline right there. Now from there, we have a little, it's called the continental shelf because it's literally like a little shelf. It's a much more shallow area. This is where most of us, if we were to scuba dive, snorkel, swim, that's where we would stay. And this is where you can see a lot of fish and animals is on the continental shelf. Because if you think about it, with the sun up high, right? With the sun up high up here, okay, it's going to warm the top part of the water. And when the top part of the water is warmed, then that's going to be the most comfortable place for creatures to live. However, the sun cannot reach its heat and its light very far down into the water, just a few, maybe 40, 50 feet, or maybe a little bit deeper than that. I don't recall the exact depth, but after, it doesn't take too long before it starts getting colder and it starts getting darker. The further down you go underwater, the darker and the colder it gets because the sun's heat and the sun's light cannot reach all the way through. So under the water, we also have undersea mountains, which are often created by volcanoes, as you can see right here. And as that volcano erupts, that hot magma will hit the water and then it will cool down, but it will add an extra layer over the top of the volcano and it will begin to grow. And that's our undersea mountain. And eventually an undersea mountain can turn into an island. An island is just an undersea mountain whose head has reached up above the surface of the water. The last thing I wanted to show you down here, guys, is an ocean trench. So a trench is very, very, very deep. It's thousands of feet deep. And it is very dark, very cold down at the bottom. And there's a lot of water pressure. So there's a lot of water pushing down on top of you at the bottom of that trench. So next time we talk for science, we are going to talk about some of the creatures that live in the ocean. We'll talk about creatures that live in the continental shelf. We'll talk about creatures that live on a reef and in the open ocean, so out where there's not a lot of this landscape that you can see. And most interestingly to me, I think these are so cool, we'll talk about some of the creatures that live in these very harsh environments at the bottom of these oceanic trenches. So that is it for today, my friends. Thank you for your attention. I'm sorry it didn't work out very well on our Zoom call today, but I love you all. I hope you have a wonderful day, and I will talk to you soon. Bye, guys.